welcome back to another YouTube video. Sorry for not posting in a while. Life has been really hectic. Anyways, we have the chem quiz coming up, so let's go ahead and review some predicting products. First, we're looking at some synthesis problems. So we have Na plus Cl2. So remember, when we're doing our predicting products for synthesis, and for actually most, you have to look, remember, what is the charge of sodium? Sodium's a 1 charge. What's the charge of chlorine? Chlorine's a 1 charge. Well, negative, but anyways, doesn't matter. So NaCl. Pretty simple, right? Because that's just, yeah. And then remember, you have to balance. Because chlorine is a diatomic, this is not balanced, right? So let's put a 2 here to make the chlorine balance, but then we have to balance out the sodium, so just put a 2 here. And I would write it out, but that's just pretty simple. Okay, next one. Let's look at magnesium plus oxygen. Okay, so crisscross our charges. So magnesium's a 2 plus charge, oxygen is a 2 minus charge. So just MgO, because the charges, like, they zero each other. Okay, and remember, it's very similar to like this problem. Because oxygen is a diatomic, we're gonna have to balance out. So put a 2 in front of that, and then put a 2 in front of that, and therefore we have a balanced equation, and we predicted our products for synthesis. Next, let's go ahead and look at some decomposition reactions. So first, we have calcium carbonate. If you look at your predicting products cheat sheet, you'll see that a metallic carbonate is one of those special rules when it comes to decomposition. So metallic carbonate turns into a metallic oxide and carbon dioxide. So if we do that, we're going to end up with calcium oxide, and because both calcium and oxygen have 2 charges, they balance out, and then plus carbon dioxide. Then if you look at that, you got 3 oxygen, 1 carbon, 1 calcium. That's already balanced. But remember, use your cheat sheet that Miss Rectanus gave us. Okay, so we looked at calcium carbonate. Let's go ahead and look at hydrogen peroxide now. So it's another one of our special rules. So if you look on your predicting products cheat sheet, you'll see that hydrogen peroxide turns into water and oxygen. So H2O plus O2. And remember, oxygen is a diatomic. Remember, Brinkelhoff, Brinkelhoff, Brinkelhoff. Write it down somewhere. Memorize it. It's super helpful when you're trying to remember your diatomics. Okay, so this, not balanced. So let's go ahead and fix that. Okay, so let's put a 2 here. And let's put a 2 here, because that makes our hydrogen balanced, and it makes our oxygen balanced, because there's 4, because 2 times 2 is 4, and then 2 times 1, 2, and then plus 2, 4. There we go, balanced. That is our decomposition. Now, let's look at some single displacement problems. Okay, so first, we have zinc and hydrochloric acid. So, remember, when we are doing our displacements, whether it be, well, let's just talk about single for now. So for single, like bumps like. Let's look at zinc. Zinc is a positive charge, and then hydrogen is a positive charge. So what we're going to do, like bumps like, it's going to become zinc chloride plus hydrogen. And make that a 2 because diatomic, Brinkelhoff, like I said earlier. Okay, so zinc chloride. And then, remember, we have to balance our charges. So let's put a 2 here. Let's put a, because it's going to balance that, put a 2 here and put a 2 here. I could be wrong, double check me. But I believe that's right. So, and then we balance that. So that is that single displacement. Then, for this one, it is copper plus silver nitrate. Okay, so silver is a positive charge, and copper is also a positive charge. So, and let's go ahead and assume that we're talking about copper 2 in this situation. yeah, let's go ahead and assume we're talking about copper too. So what we're going to do is going to CuNO3 with a little 2 because nitrate has a like 1 charge, so it doesn't affect the copper. And then plus Ag, which is our silver. So we have that. So we gotta put a 2 in front of the silver nitrate to balance that, and then a 2 in front of the silver, and I believe that is a balanced equation. So there is our single displacement. And something I want to talk about with single displacement is that when you have single displacement or, double displacement, in order for something to react, it has to be like, say for example, in the lab we did the other day, the reason why copper did not react in the zinc solution is because in order for a reaction to occur, the substance has to be more reactive than the other. The reason why zinc reacted in the copper solution is because zinc is more reactive than copper, therefore allowing the reaction to happen. So when you're looking at these displacements, you have to remember that. I don't think she'll throw anything on the test that'll mess us up, but it's just something to keep in mind. Because in order for a reaction to occur, something has to be more reactive than the thing that it's reacting with, if that makes sense. Next, let's look into some double displacement. So first we have, sodium, let me check my periodic table, sodium sulfate, plus barium chloride. Okay, so remember, with our double displacement, we do our outside and our inside together. So let's do oh my gosh, my pencil lead just broke. Anyways, and then, so it's going to become NaCl. And remember, because Na and Cl both have 1 charges, it just becomes NaCl plus, what's barium's charge? I have to check that. Okay, barium and sulfate both have a 2 charge, so it's just going to be BaSO4 with no Roman numerals because, yeah, okay. And then in order to balance that, because you see our little underscores here, just put a 2. Oh my gosh, my pencil lead. I'm gonna crash out. Anyways, let me just grab a pencil. Okay. That balances out. If you put a 2 in front of the NaCl, that will balance out there and there. So that is a balanced equation with double displacement. Okay, sorry if you couldn't see that, but here's the final equation. And then we look at lead 2, because you see the little thing here, lead nitrate plus potassium iodide. So let's go ahead and do that. So Pb iodide has a 1 charge, so PbI2 plus K, potassium has a plus 1 charge, and nitrate has a minus 1 charge, so NO3. And so in order to balance that, we're going to have to put a 2 here because of the nitrate having a 2, and then we're going to have to put a 2 here because that'll balance out the potassium, and that'll also balance out our iodide. Okay, so here are our balanced equations for double displacement. Now, let's go ahead and get to our last type of reaction. Remember, it's a combustion, but also there is such thing as neutralization, which is an acid and a base, which always creates water and a salt. I'm not going to go over that, but it is on your predicting products cheat sheet. Like I said earlier, please use that. That is an amazing resource, and it's super helpful. Okay, so combustion. What are our products for combustion? Let's see. Duh, it's always water and CO2. There we go. And the only issue is balancing. Dun dun dun. Anyways, that was kind of cringy. So we're going to put a 2 in front of our HO2 here because there's a 4 here, and then for oxygen, be 4, and so let's go ahead and put a 2 here, and I believe that's balanced. So yeah, that's a balanced equation. That was pretty easy, right? And like I said, I think combustions are the easiest ones because you automatically know the products. You don't have to be like, crisscross the charges. No, it's just water and CO2. So for this one, I'm probably gonna have to put more effort in than I would want. So I'm just gonna do my little balancing things like you guys saw in the last video, because it's really helpful and it's something that keeps me on track in what I do. So, okay, 2. There needs to be 3 carbons. So 3, and then there's 7. Okay, put 4. Yes, okay, and then we're gonna put that, and 3, 8, and then we're gonna go ahead and have 10 oxygen, and then put a 5. Yep. So 3, 8, 10. There we go. Balanced. I don't know if you can see that because anyways. But yeah, combustion, one of the easier ones. You just have to balance it pretty much because you already know your products. Okay, so that's going to be it for today. I will probably post another video this weekend about solubility rules if I can remember or if I have the time. So yeah, I really hope this video was helpful and helps you review for our CAD test. All right, bye everyone.